Let's consider this computer program here, and we can see that it has x is assigned 2, and further down in the program you can see it says x is assigned 3. Now it's usual when people think of assignment statements like this one here, x is assigned 2, to imagine that a box appears and that a number 2 is placed in the box. And when we then come down to this particular statement, x is assigned 3, well, we've already can see we've got the box x, so we'll take out the 2, throw that away, and replace it with the 3. Now the thing is, within Python it doesn't work in this way. Within Python, when we see an assignment statement, we need to think of it slightly differently, and the way in which we need to consider it is as follows. When you see x is assigned 2, x is a name with a binding to the integer object 2. So when we see x is assigned 3, we have to realize that x is a name with a binding to the integer object 3. Let's consider this computer program one program statement at a time. First of all, let's have a look at its runtime. We can see the runtime here. So let's now see what happens when we have x is assigned 2. We will have the execution space, and a class will be used to produce an object, and this object is labeled with x. Now x is the name that actually is bound to the object, and the object you can see here has the value of 2. Now these three print statements print these values to the screen, as you can see here. Now the object you can see in the execution space that's labeled with the x is an example of an immutable object. Now that means it cannot be altered once created, and I'm going to represent that with this circular shape here, this red circle, bold red circle appearing round it, emphasizing that this is an immutable object, which means that you cannot change this value. The 2 cannot be replaced with something else. But later in the program you can see x is assigned 3. But remember, the notion of this box that we were looking at earlier in the video doesn't exist in Python. So when we get to this program statement here, x is assigned 3, what will happen is another object is going to be created as represented by the animation here. And you can see that this particular object is given a new ID. Compare this ID with this one, you can see the difference. They both are given the same type, as you can see here and here. But if you have a look at this one, it's got the value of 3, while this one maintains its value of 2. But what also will now happen is the label that's labeling the object here is moved, and it's moved to here. In other words, x is now attached to the other object that's come into existence. Therefore, x is the name that is bound to the integer object that has the value of 3. So what happens to this object here now? Well, it has not got a label attached to it. It is now unnamed. And of course, what Python will do in these circumstances, it will mark it for garbage collection. But before we see what actually happens there, let's now have a look at these three print statements and what they give. These three print statements will put these values here on the screen. And if you have a look at this ID and this ID, you can see that they are different. And of course, the values are different. Now, the reason the ID and the values are different is because we have two different objects. You see, these outputs came from this object, and these outputs came from this object. And now this object has got the label X, because that's where we're up to in the program. So the object that did have X, as I've already said, is marked for garbage collection, so it is eventually removed by Python. Let's consider a different computer program, this one shown here. And in this program you can see we have this line saying y is assigned to, which we must in Python think of y is a name that is bound to the integer object 2. And further down you can see this one, y is assigned y plus 1. Now this is the way in which we usually can increment variables in programming languages, because you work out what's on this side, and whatever's on this side is given to this side here. But in Python we need to think carefully about what's actually going on here, and we're going to use the model we've been discussing in this series of videos to assist us in understanding what this will actually do for us. So if we now have a look at the runtime for the program, we can see it's actually here. And let's explain how we get this particular runtime by single stepping through the program. Well, the first thing is when we have y is assigned 2, we will have the execution space, and from the integer class we will produce the integer object, and the label is the name that's bound to the object. And if you look, you can see that the object has the value of 2. It also has an ID, and it also has got this here saying that it is an object of type integer. Now this particular line here, print the ID of y, we locate the label, this is the ID, it gets printed to the screen. This one, print the type of y, we locate the label, this gets printed to the screen. We print y, we locate the label, we get at the value, and you can see that's printed to the screen. Now when we get to this line, y is assigned y plus 1, we're going to find out that we're going to have to take this side of the expression y plus 1 and do a calculation. And calculations in computers are done by the arithmetic and logic unit. So I'm going to show in the animation an arithmetic and logic unit appearing. And of course the object that exists at the moment is this one, and we can see it's got the value of 2. So that 2 is moved to the input of the arithmetic and logic unit, and of course we can see from the calculation that there's a 1 here, and of course that 1 is added to the arithmetic and logic unit at its other input. And of course this plus sign here means that we're going to ask the arithmetic and logic unit to add up, so we send the appropriate signal, and obviously the arithmetic and logic unit will add its inputs, which is the 1 and the 2, and it'll give us the result of 3. Now what we have to remember is the object that's in existence at the moment, y, is immutable. And I'm going to represent that by putting this bold red circle around it, which means that this particular value here cannot be changed. So it isn't possible to take the output of the arithmetic and logic unit, which is the 3, and actually give it to the object that currently exists, the y, because it is immutable. It cannot be changed. So, armed with the result of 3, what Python will now do, it'll create another integer object as shown here. And we can see that its integer object takes up the value of 3. Now, this label which is attached to the original object is now moved to here. It's said to be rebound to a different object. And of course this object we can see has an ID, it has a type, and it has the value of 3, which is what we would expect if you're going to increment y that was 2 by 1. It'll obviously become 3. But it now begs the question, what about this object over here? Well, that one now no longer has a label. It was used, but now it doesn't have a label. In other words, it's unnamed. It's not bound to anything. So Python will mark it for garbage collection, and indeed it will disappear. So now when we come here to print the ID of y, we're actually dealing with the object that exists now, not the old one that the garbage collector will at some future point in time get rid of it. I've shown it gone already. So when we come to print the ID of y, we print this to the screen. When we print the type of y, we print this to the screen. And when we print the value of y, we print this to the screen. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and get an automatic update every time I upload a new video. Also consider subscribing to the Google Plus circle that relates to these videos.